Hello. Right. Quick one now. We're just going to have a quick look at how to differentiate curves that have been defined parametrically. Okay. So those are curves that are defined something like instead of saying y equals a function of x, we define both x and y separately using a parameter which could be t, or it could be theta. I mean, it could be any letter, but usually t or theta are used. Okay, so I'm not going to go into any more detail about what these curves look like. There is obviously a whole section on parametric equations where you look at this in more detail, but I'm just looking at the differentiation because it's quite straightforward. And then we can say we've pretty much finished differentiation for year 13. The way we're going to use this is we're going to use the beauty of the dy by dx notation. Now, dy by dx is not actually a fraction. It's the rate of change of y with respect to x. However, it's such a good notation. Leibniz invented it when him and Newton were independently discovering calculus in the 1700s. We don't use Newton's notation anymore, but we do use Leibniz's because it makes things a lot more simple. So although it's not technically a fraction, in many ways it behaves like a fraction. So you'll see that in differential equations later on, but also here, if we want to get dy by dx in terms of this other parameter t, well, we could just do dy by dt divided by dx by dt. Okay, now if dy by dx, dy by dt, and so on were fractions, that would be obvious. We just know that when you get two fractions with the same denominator like that, the denominators cancel out, and we're just left with dy by dx. So if you just think of it as being like a fraction, then you find dx by dt, you find dy by dt, then they are related in the way that you would expect. So in this example up here, so if we take the example that's there above, we can see that dx by dt, sorry, dy by dx is going to be dy by dt, which is -1, over dx by dt, which is 2t, and that's it. For that function up at the top, that's what we get. Okay. Did I take the question? I don't think I took the question that I wanted. Let's just go grab it. We're just going to look at one past paper question. And then in the next video, we're going to try and really dig down and revise all these different differentiation techniques by going through as many past paper questions on differentiation as we can find. So that's probably going to be quite a long video, but it definitely will be the best place for you to practice differentiation. Okay, so here's the question we're going to take a look at. Again, if you've not covered parametric equations yet, there's no harm in learning this now. It's absolutely fine to just learn the differentiation part of it first. Okay, so first of all, we've got this curve which has parametric equations. The parameter, which is where the word parametric comes from, in this case is t, and it's between pi over 8 and pi over 3. So yeah, and these equations are used generally to describe curves where we're not necessarily sure how the y-axis interacts with the x-axis, in a real life situation, but we might know how the x-axis changes over time, and that's why t is often used, and we might know how the y-axis changes over time, so they're both defined in terms of that third parameter. The third parameter is sort of like a dummy variable. You won't see t appearing on the graph anywhere. Anyway, so for part A, we need to first remember dy by dx equals dy by dt over dx by dt. So that will be, okay, so dy by dt, we've got 7 sine t, which becomes 7 cos t, and sine 7t becomes cos 7t. Sorry, 7 cos 7t, using the chain rule. And that's divided by dx by dt, so that becomes minus 7 sine t, and the cos 7t will become minus sine 7 sine, so that becomes plus 7 sine 7t. Oof. It says you need not simplify your answer. So that, as much as I want to simplify that, we don't need to. So maybe I should just leave it as it is. Maybe I'll put in brackets. You know, if we did want to simplify it, it would look like cos t minus cos 7t over sine 7t minus sine t. Okay. B, find the equation of the normal to the curve at the point where t equals pi over 6. So we're dealing with normal. So a normal is a straight line. So we are going to use y minus y1 equals m times x minus x1. And then we will need to find y1, x1, and m. Now, in this case, we have not been given x1, y1, or m. So we've got to work out all of them. So let's first work out x1 and y1. Now, we've been given that t is pi over 6. So we use the original formula that's given to us at the top. So x1 will equal 7 cos pi over 6 minus cos 7 pi over 6. Okay, so pi over 6 is 30 degrees. And so, oops, so that will be 7 cos of 30 being root 3 over 2 minus cos of 7 pi over 6, which is 210 degrees. That's root 3 over 2 as well. Okay. So that equals 6 root 3 over 2, which is 3 root 3. For y1, we use the other part, so 7 sine t minus sine 7t. Just double check sine of 7 pi over 6. It is minus a half. Oh. Ah, yes, the cos one was negative as well. Sorry about that. So this is 8 root 3 over 2. Right, that makes more sense. I knew something was wrong there. Right. So 7 halves plus 1 half is 8 halves, which is 4. And now we need to find m. So to find m, it's going to be cos t minus cos 70 all over sine 70 minus sine t. Fortunately, we've worked out all those. So that will be root 3 over 2 plus root 3 over 2 over minus a half minus a half, which is 2 root 3 over minus 2, which is minus root 3. So finally, we can now put that. Oh, so no, sorry. Our m then equals 1 over root 3 because we're wanting the normal. That's the gradient of the tangent. We want the normal. So now we can work this out. We've got y minus 4 equals m times x minus x1 was 4 root 3. So how does it want the answer? It just says in its simplest exact form. So I'll multiply everything by root 3. Or maybe not actually. Let's just, no, I'm just trying to see how I can get this nicely simplified. So those 4's cancel out. And then x over root 3, we just need to, let's write that in surd form. So multiply the top and bottom by root 3. We get root 3x over 3. And that's it. The 4's cancelled out. So that's it. That's all. Hopefully that was helpful. And please join me for the next video where we will be doing a whole bunch of past exam questions, and you'll get to see me making many more mistakes than that one where I dropped the minus sign. So it could be entertaining. So see you later.